All right, so let's talk Lewis structures. I'll give you guys some background and then I'll show you guys my method that I like to use. So if you guys remember from yesterday's lesson, I talked about the 3 different types of questions you're going to get on this exam. The first is going to be the types of solids, which is what we reviewed yesterday. The second one is going to be on Lewis structures, shape, and polarity. So there's 3 kind of subtopics in the second question. Now, the first thing we have to think about is what are Lewis structures and why are they very important to understand? First off, the Lewis structures, if you guys remember talking about it last term, were those guys that basically had, and now I'm trying to decide what I had on my wand. It was stuff like this, if you guys remember. You were drawing lines and dots and writing things with the chemicals formula. So that's an example of a Lewis structure, and that is a Lewis structure for oxygen gas. This one is oxygen gas, if you guys were wondering what that was. So Lewis structures are really useful to us for 2 reasons. The first thing is that it can communicate to us where the valence electrons are and also how many of those valence electrons are in bonds. Are we okay with that so far? All right. Now, this is going to be really important as a foundation question. If you guys remember yesterday, I was talking about the types of solid question, and I said the first step with the types of solid question is making sure you identify things correctly. If you don't identify things correctly, it then snowballs, and your whole long answer will be marked as incorrect, and you won't get any points. So unfortunately, an achieved kind of requirement really affects the merit and excellence points later. So you need to be able to do that first component well and correctly. Lewis structure, shapes, and polarity, this second question is very much in the same kind of category. If you don't get the Lewis structure correct when you draw it, it snowballs, and then when you answer the second part of the question on shapes and polarity, then that section is often incorrect as well. So we need to make sure we get the Lewis structures correct. So I'll write that down. Very important to get correct. Because it will affect your shape justification. That's something that we have to keep in mind when we're answering this question. So do not rush the Lewis structures. I know it seems really simple. I know they're generally only achieve points when it comes to the exam, but if you get it wrong, it's going to hurt you later down the track. So do kind of keep that in mind when we're doing this work. Don't rush it. So when we're thinking about Lewis structures, the first thing that we need to be able to do is to grab the number of valence electrons for each atom. The way you're going to do that is by using your periodic table. The periodic table, by the group numbers, tells us how many valence electrons that you are working with for each type of atom. So the periodic table is arranged in a logical manner. One of the ways we do arrange it is by having like categories. So everybody in group 1 has 1 valence electron. Everybody in group 2 would have 2 valence electrons. I'm just going to abbreviate that as VE. We don't worry about the middle bit. Group 13 has 3 valence electrons. 14 would have 4, 15 would have 5, 16 would have 6, 17 would have 7, 18 would have 8. So that just tells us what we're starting with when we're working with our valence electrons. And you guys should hopefully have maybe picked this up earlier in your science learning when you guys were talking about ions and ion charges and how they all kind of group together based on that. Are you okay so far? Okay. The second thing we have to keep in mind when we're talking about our atoms, and again, you guys would have talked about this in ions, is reaching the octet rule. So atoms are going to be more stable if they have a full outer shell. So you guys talked about this last year with ions and about them gaining and losing electrons in order to get that full octet. In this case, when we're talking about covalent molecules, instead of them transferring electrons, they're going to be sharing electrons. And by sharing those electrons, they'll be able to get their full valence shell of 8. Are we okay with that so far? So those are 2 things we have to keep in mind when we're doing this. So first thing, keep in mind is that we take the valence electron number from the periodic table. And then the covalent bonds will share the electrons so atoms can get their octet and be stable. I'm just trying to find the word octet so I can spell it correctly. Are we okay with that so far as kind of like our first kind of ideas? I like to give you guys the reasonings to why things happen so that way you have some background information. Be mindful there are going to be 3 exceptions to the rule. So most of the atoms we are dealing with, the number that we're trying to reach is 8. There are 3 that will be stable without 8. The first one that will be stable without 8 will be hydrogen. It will be stable with 2. The second one is beryllium. It will be stable with 4. And the last one is boron. It will be stable with 6. So these guys don't need to reach the 8 rule to be stable. All right, shall I dive into some examples? I was going to do 4 examples, but I was going to see how you guys feel. I wanted to do a variety of different things so that way you guys can see it in different settings. I'll let you guys catch up because you guys are still writing. Questions at this point? How confident were you guys feeling about Lewis structures last term? That was a face that said not confident. Okay. We had a thumbs up, so some people got it. All right. Examples? Okay. The first example that I'm going to give you guys is ammonia, which is NH3. This is one of the methods that you can use to figure out the Lewis structures. There are actually 2 methods you can use. I'm only going to teach one of the methods. The SciPad has, I think, the second method. The reason why I teach this method is because this one's more useful for level 3 chemistry. Right now, we're only talking about really simple molecules, but at level 3, we talk about bigger molecules. And so this rule or this set of instructions work better for level 3. All right. First thing I want to do is I want to figure out how many valence electrons I'm working with. So that's step number 1. How many valence electrons? For those that are kind of confused on what the word valence mean, I'm talking about the outermost shell. Of my atom. So let's go through and make a list. The first one I have is nitrogen. When I look at the periodic table, I see that nitrogen's in group number 5. So that tells me 5 electrons. And then I want to multiply it by the number of atoms in the formula. In this case, I only have 1 nitrogen. So I'm doing 5 times 1, That's 5 electrons I'm working with. We good so far? The next element that I have in my molecule is hydrogen. When I look at hydrogen, I see that it only has the 1 electron. It's actually in group 1. It should be up here, but sometimes they move it out so that way they can label it. So hydrogen only provides 1 electron. There are 3 hydrogens, so I have a total of 3 in that case. And when I add these two numbers together, I have a total of 8 electrons. Are we good so far? All right. Second step is that I need to put together my molecule. When I put together my molecule, I assume that every atom needs to have at least 1 bond, so that way there's no free-floating atoms floating around. When it comes to what I decide as the center atom, there's 2 things that I could consider. First off, just the quantity of the different types of atoms. Usually the one that you have in the least amount, in this case nitrogen, would be the center atom. The other thing that I factor in is how many bonds could each one do. So if I was looking at nitrogen, it has 5 electrons. It can do 3 more bonds to get up to 8. If I'm looking at hydrogen, it wants to get up to 2. It only needs 1 more electron to do that. So it's only going to be able to have 1 bond. So from that logic, I should put nitrogen in the center because that one is going to be able to have the most bonds. I assume that everyone needs to be connected with 1 bond. Are we okay with that so far? So that's step number 2, connect together. Connect. And assume 1 bond. Because that's how it needs to be in order for things to fit together. These lines here represent 2 electrons. You could also draw it as this, with the bond, with the electrons being shown as dots. Both of these are considered correct. Personally, I prefer this one because it helps me distinguish what electrons are in bonds and which electrons are not in bonds. But it's up to you. The next thing I do is I need to then think about how many electrons do I still have left. So right now I have 2, 4, 6 electrons being used, and I have a total of 8 electrons available. The next rule is I need to add electrons to my molecule, and I start from the outside going in. So I check, are the outer atoms already filling their stability rule? And if they are, then I put it on the center atom. So if I look, hydrogen, 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 all of them have 2 electrons to them. And I know that because hydrogen is an exception to the rule, it is stable with 2. So I'm not putting any electrons there. I then can put the electrons on my center atom, in this case, nitrogen. So I'm going to put 2 more here. 1, 2. And I'll also show it on this guy here too. So start from the outside going in. So step 3, add remaining electrons. Going from outside in. And then step number 4 is I want to double check to make sure everyone is stable. So I look to see, does hydrogen have 2? Yep. Does this hydrogen have 2? Yep. Does this hydrogen have 2? Yep. Does nitrogen have 4? 2, 4, 6, 8. The nitrogen's fine as well. Everybody's stable. I know I have my Lewis structure correct. I'll do a couple of examples because I know they get kind of more complicated and kind of confusing at times. Questions, concerns, comments so far? All right. Move it. All right, the second example that I will do, getting a little bit bigger as an element, or I shouldn't as an element, as a molecule, is CHCl, and these are going to be 2 and 2. So that's my next molecule as my example. I do the first step again, go through all my atoms, figure out their valence electrons, figure out how many I have as a total. So if I have carbon, sorry, going out of focus. There we go. Come on. Doesn't like me. Okay. Carbon's in group 14, so it has 4 valence electrons. I only have 1 carbon, so I multiply that by 1. I have 4 valence electrons coming from carbon. Hydrogen's my next one. Come on, focus. Hydrogen we did previously. We know that one has 1 valence electron. This molecule tells me we have 2 hydrogen atoms, so there are 2 electrons coming from there. Come on, focus. All right, last one is chlorine. When I look at the periodic table, chlorine has 7, because it's in group 17. And how many is that? 2 equals 14, and then we add all these guys together, 20. That's what I'm working with. All right. When I'm looking at that, which one do we think is going to be the center? Oh, sorry. Looking at your molecule and the list of all the things I have, which one of these 3 atoms is going to be my center atom of the molecule? Carbon. Yeah. So carbon can do 4 bonds. Hydrogen can only do 1. Chlorine can only do 1 because it only has space for 1 more electron. So we place carbon in the center. We assume everybody has to have 1 bond. Doesn't matter where you place the hydrogen or the chlorine. You can place them like this. That's still correct as well. So I'm not fussed where you place your atoms, so long as you have the right atoms there. Are we good? Both fine. All right. I have used up 2, 4, 6, 8 electrons, correct? So if I subtract away 8, how many do I have left? 12. All right. We are working outside going in. Are the hydrogens fine? Yep, because they already have 2. Are the chlorines fine? No, because they need 8. So we start placing them on the outside atom, and then if there's any left over, then I put it on the carbon. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Have I used up all my 12? Yeah, I have. I'm just going to put it on this one too because it's going to drive me nuts if they're not all there. All right, last step. Double check to make sure everyone's stable. So we know the 2 hydrogens are stable. Are the 2 chlorines stable? Yep, and then is the carbon stable? Yep, I'm done. That's what that molecule looks like. That's it. I have to show you guys some harder ones, though. Never mind. All right, you ready for a harder one? Okay. I'll switch colors because I like to switch colors. That way you guys have different examples. All right, next one I have is carbon dioxide, CO2. Carbon has 4 valence electrons. We only have 1, so that's 4. Oxygen, 6. It's in group 16. How many do I have? 2. So 6 times 2, 12 total. 13. Am I doing math right? Are we okay with that? Okay. Which one do you think is going to be in the center? Carbon. Carbon tends to be in the center, and if you do level 3 chemistry, you'll learn about organic chemistry and why carbon is the king of all elements. Carbon can do lots of bonds. All right, we assume there has to be at least 1 bond to put the oxygens attached to the carbon. All right, I have used 4 electrons, so minus 4, I have 12 left over. Are we happy? All right. Now we place the electrons outside going in. The oxygens are on the outside, so I do the oxygen first. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Yes. That's what we're going to do to fix the problem. Because right now, when you look at it, you're going to realize oxygen has 8. That one's fine. This oxygen has 8. It's fine. Carbon, not fine. Only it has 4. So what we're going to then do in this case is we're going to move some of our electrons around so that way my carbons reach the octet rule. What we're going to do is we're going to take some of these lone pairs of electrons and we're going to move it so that way it forms a double bond. So like, for example, I'm removing these 2 from here and I'm placing it in there. And I do the same for the other side, removing these 2 electrons, placing it in to form the double bond. So if I was to clean this up and I was to draw this properly, I would show C, double bond C, double bond O, and then 4 valence electrons on each oxygen. So that's just it, the same thing tidied up. And again, if we go through and double check, now I have on my carbon 2, 4, 6, 8 carbons now fine. So you just got to move your electrons around if they don't match up. Again, so long as you have the right number of electrons and the right number of bonds, you'll be marked correct. So if you do, for example, this, and have your valence electrons on the side of the oxygen instead of up and down, both of these would be marked as correct. We're not going to be that nitpicky. The main thing we're checking is, do you have the dots where they're supposed to be, and do you have the lines where they're supposed to be? And again, if you want, you can show it as all dots, like that. If you rather show dots for everything, that's fine. That's also correct as well. But when we do shapes next week, you'll see why I prefer this method to that method. Do you guys want one more example, or you think you're okay? You're okay? You guys okay? Looks like you guys are okay. Okay. All right, so that's what you got to do. I'm going to pause this in case you do want questions later.